come to the final panel. It's actually probably more of a fireside chat, however we qualify it. But Malak's going to moderate a conversation with Julian van Velzen, who's Director of Quantum Lab at Capgemini. The management consulting perspective will be interesting. And then Christophe Legrand, who's Senior Vice President of Sales at Pasqal. And their conversation is titled Scaling Quantum from Proof of Concept to Deployment. So putting the furniture together. Turn to the person next to you and ask if they're connected on LinkedIn while we're waiting for that. It's like they do in church. Now that they're said, a formal welcome to the final panel of the day. All right? Yay!
Thank you so much for making it up to the end. Actually, I tried my best that we are having a very interesting panel at the end, so we keep having some audience. So it's not the end of the conference day, it's the opposite. I wanted to have a very nice fireside chat with two of the best I know. Thank you for being here. So we have Christophe Legrand, Senior Vice President Sales from Pasqal, and Julian van Velzen, Director of Quantum Lab at Capgemini. Again, thank you for staying the whole day for this fireside chat. It's great to have you here. So, as we have reached one of the most anticipated conversations of the day, which I see one of the leading companies in the quantum industry, and one of the leading, let's say, consultant companies which started early in quantum. And when I started in quantum, it was 2020. I was following what's happening and who's been there and out. And one of the people I reached out to, Julian, you were busy all the time. And it was very difficult to get hold of you. But thank you so much for making it. And very proud of the work you do and the team that you have. I would like to pass you give you the chance in order to introduce yourself and the team you're working with and what you do at Capgemini before I move to what Pasqal is doing.
Thank you, Malak. And thank you so much for inviting us here. It's an amazing day so far, wonderful sessions. So I lead our quantum team. So I would say Capgemini is not only a consultancy company. We have a small part, about 10% of the company that does sort of strategy consulting. About 40% is technology implementation, so all kinds of IT systems, and now 40% is engineering and research. And then the quantum team mostly comes from the engineering and research department, but also a bit from the other teams. And so what we try to do is really, as a service company, try to see how quantum makes sense and how we can build workflows that incorporate all the best solutions from IBM and from Kipu and from many of the other IT guys that are here into end-to-end workflows. And so primarily we do that in quantum chemistry, material science, and of course Pasqal. Chemistry, material science, but also a few other fields.
So I missed the other, you said 10% consultancy and...
So roughly 10% strategy consultancy, 40% IT services and development, and 40% engineering services.
Perfect, yeah. So I missed all the rest. Okay. Christophe, it's your turn to present yourself and Pasqal and what you are doing.
Sure. So what the pressure you put on us first. So thanks a lot for the invitation. So happy to be with you today. So at Pasqal, so I work at Pasqal since 3 years now. Before that, I was a sales leader in France for NVIDIA. So I know pretty well how AI, HPC could be combined with quantum. So when I started at Pasqal 3 years ago, I was mainly the only sales guy. Now I have a fully team worldwide. Partially, only I would say 30% of my team are quantum experts. All the rest are business people, including partnership and sales or business development. So at Pasqal, from the beginning, so only from 6 years ago, We are developing a full stack approach, so the hardware and the software. Pasqal computing machine is based on neutral atoms. So yeah, we are in this field from only 6 years, but we are seeing a lot of improvement, and thanks all to our ecosystem. But I will come back on that later.
Perfect. So looking at the bigger picture, and we often hear one thing the last few months. Quantum is at an inflection point. Are we talking really about value and its real inflection point, or its hype? Who I start with? Julian, it's your call.
So I think we're at a very interesting moment. If you look at for example, the video from IBM before, those big machines that will be able to run 100 million gates and 200 qubits, they are being developed today, right? Those plots are being bought, those machines are being deployed. We are starting to be in a scaling phase to really build large-scale machines. We are seeing that companies are starting to take it more serious. We started with a small proof of concept, very initial demonstrations of algorithms, and increasingly we were moving towards end-to-end workflows where we see much more realistic, no longer toy models. But I think there's a long road to go. I think there's still a vast majority of the papers that are currently online is about algorithms that aren't practical in the real sense, that have not end-to-end resource estimations, that have not been estimated, for example, with error correction, overheads, all of those type of limitations. I think that's where we are coming from, and we are moving now towards this moment where we are seeing more real applications. There is still a long road to go, and much more work to be done. But I think we are at a very interesting point where we can really see that there is value coming. At the same time, I would maybe also stress that there is no more moment to wait for post-quantum cryptography. And so that is really an inflection point right now where there is no moment to wait to start deploying.
Exactly. You touched upon very, very important part, which we talked about it this morning. Christophe, what do you think? Are we at this real inflection point where quantum started delivering value, or we are into still hype?
It's still a global question and a tough question, but I see different point of inflections. The first one is we are reaching not the advantage, for sure, but we are touching the point where we could prove some advantage. So not a global or a full advantage of regarding what a classical computer can do, but on some specific use cases like in material science or in specific optimization problem, we could find how to resolve efficiently the problem, plus, and this is maybe the new factor, how to be more efficient in terms of energy consumption, to do exactly the same. So in a sense, it could be a point of inflection. The second kind of inflection we see is that for the first time, a couple of months ago, we had the chance to sign a contract with a big corporate that bought a machine, a Pasqal machine. It was the first time ever, I think, in the quantum world, where a big corporate bought a machine for his own usage. And the third point, and we just announced a couple of months ago, again, a great partnership with IBM, and we see that a lot of different typology of hardware are partnering to serve the same goal, is to find a way to accelerate this point of inflection by introducing some hybridization, not only on technical but as well on the business side.
Great. So my question would be about scaling. The delivery of machines is very interesting, and what is more interesting is scaling, and to have to go beyond use cases. And I remember we talked with Damir during the Quantum Innovation Summit in one of the panels, and I told him and highlighted, I said, well, the real value that we would like to see is real business. And his question was, what do you mean about real business? It's like beyond use cases is what is after that. So this is my question. Do you see that the scaling with this inflection point means that we started having other than use cases?
I would say no, because it's really relative to the market. If we compare the quantum market with the HPC or AI market, so just if we compare the NVIDIA business and whatever the quantum company could be, for sure we are not at scale, for sure. So it's not the same story for sure. So that's why my direct answer is no. But depending on the different category of the scaling, because here we could talk about technology, but I would talk also about the ecosystem and how we can, or what we can do to scale the ecosystem. So maybe it has not been a lot discussed today, but I think this is really key. So Ahmed from IBM, it was the last slide or one of the last slides. So I liked a lot this approach. Scaling the community, scaling the ecosystem is maybe at a point where we could say yes. But on the technological standpoint, the answer is no.
I agree with you. The ecosystem and actually complementarity is very, very important, and economic of scale. So these are the points that I believe in ecosystem is important, and not just, some people, they think ecosystem is bringing people together. It's not that. It's what you create, what is the added value. And that's why with what we are doing and with Abu Dhabi Maritime Academy, we aim to have actionable outcome from what we have, because having events and going and at the end of the day, you are spending a full day in an event, and what is the outcome of it? So here, the ecosystem is activated in a way that it serves the interest of the different stakeholders. So what I would like to go to, I hear so often Julian speak about value gap, and about the value gap or the quantum value gap. And what are the key lessons from the pilots you have seen? What are these value gaps, and how do you see them, and how the audience, and actually this is also is recorded, so people that will be watching later, what would you tell them?
So quantum computers are increasingly sophisticated. They may or may not actually do something useful or advantage, but at least we're in a moment in time where it's arguable, and they're increasingly sophisticated. But the challenge is, are we ready to really use them optimally? Do we really know how they integrate into end-to-end workflows? Have we done full error correction and error resource estimations? Have we done noise profiles? All of these questions that you start considering when you start getting real applications. And I think there's a very long distance to go still. And so this is what we call the value gap. So the increasingly wide gap between what the hardware can do and what end users are capable of using. And so I think what is really necessary to close that gap is that in the past we've really had a sort of technology push. Hardware providers, but also companies trying to see, this is cool technology, what can we do with it? And I think what we need to do now is really turn that around. We need much more application pool. So not starting with a QoA algorithm or a QPU or whatever type of algorithm and see what we can do, but really change it around, start with your use case, start identifying the computational bottlenecks in that workflow, trying to see, are there any of these computational bottlenecks that could potentially be run on a quantum computer, and then do a full, honest resource estimation, including overhead like error correction and state preparation, but also making an honest assessment of the economic cost, right? And I think that is really what is necessary to close the gap between what the hardware can provide and what companies could use eventually.
If I ask you how many, maybe roughly, pilots that you have done with the quantum team you have?
So we have, we prefer to have a couple of really deep pilots rather than a lot of very small ones. So we have a number of customers, let's say 7 or so. Many are published, for example, Airbus, GSK, Unilever, Total. where we have really done this application research with, where we started with the use case and then developed embedding methodologies, ways to connect quantum chemistry with quantum computing technology, etc., to really see how quantum computers could be used. But then there's a much wider group of companies that we've interacted with over the years, maybe did some training or some workshop or some awareness type of thing with. But that's usually much more superficial, right? So I think really what would help the industry most is maybe a few sort of moonshot projects. So companies that really shoot for the moon, that develop all the technologies, the whole stack that is required to get there. And then even if the use case changes in the end, that doesn't really matter, right? It's what matters is developing all the different technologies along the way. And so that's what we're trying to do with the handful of companies that we go really deep with.
Before I go to Christophe, there's one thing I would like to add. How do you see, or how organizations can design proof of concept project that can lead somewhere, not just designing a concept and it's a proof of concept, then it's going to stop there. So what is the best way how to look at it in order, or what do you advise to move forward somewhere that can be implemented and adopted?
So if it would be one word or two words, one word, it would be application pull rather than technology push. Right? So start with your use case and then figuring out if quantum computing fits in, but really see quantum computing as just a tool. Try to be honest if there's other technologies that perform potentially better. That's also a good solution, right? Because in many cases we have seen that there's a lot of room to innovate even without quantum computers. Right? Maybe some quantum chemistry tooling, maybe you can do a lot with just DFT, or maybe in quantum chemistry or in optimization, there's a lot you can do with Gurobi or Cplex. And that is a very fair finding as well. So start with the use case and then drill down.
Exactly. I remember I did one show before, and it's about the linearity and non-linearity of R&D, and how, for example, DARPA, they do a lot of projects to go for something or some project, and the result is totally different than what they prepared. So this is the way how innovation works, and as you said, is moonshot is very, very important. So this will lead me to Pasqal, Pasqal, the company, one of the industry leaders, which is moving forward with a lot of projects and pilots. I'm not speaking about the hardware here. So you are from the other side of the equation. When you have a potential use case or problem to be solved, do you choose it based on the outcome that it would lead, like the value that you see, or you just take the chance in order to make it happen and you see how it's going to be adopted later?
The simple answer is now, yes. At the beginning, no. That's why we improve maybe more than 40 use cases in the different verticals, different type of algorithm. But now we are choosing the algorithms that could be run on our machine. All the rest, I mean, it's not, first, to develop algorithms, this is not core business for us. Why we are doing this? Just because we need to show the direction to our ecosystem, how to use a Pasqal machine. But the development of algorithm comes to our partners like Capgemini. This is not our business at all. So to answer to your question, Malak, yes, we are choosing the use cases. We are choosing our type of algorithm, and more we are, and this is a good discussion we have with the majority of our customer. We need to prove that there will be some value as an outcome. ROI sometimes, not often, but could be in some cases. That's why we are working a lot as well on the peripheric outcomes. That is maybe not direct to the business or not direct to the technology, but it could be the enablement of a team, of part of an ecosystem. It could be a question of energy efficiency. I mean, it could be a lot of things around, but it could prove value, and it could maybe help to close the gap.
Exactly. So about maritime, I know that you have very famous use case that you worked on. Can you tell us about it?
Yes.
I think you were one of the first who worked on something after maybe D-Wave.
Maybe because and it has been announced. We are partnering with CMA CGM, so it's a global logistic company that I'm sure you already know. So we are partnering because CMA CGM invested into Pasqal first, and second, we worked with them on container optimization for their big boats. So for a couple of boats where the storage of containers is not optimal, even if they spend a lot of money and time to find the best optimal situation on every container, still whole in the boat. So we had, and it was really successful. We had a really great project with them on that. A part of not linked directly to the maritime verticals, but it could be linked because we worked on fleet management, traffic management as well with other companies, not on maritime or boat fleet, but it could be adapted easily on this part as well.
I think it falls under the blue economy, so yeah, you're good. So the next question, and I would stay within this industry, Julian, how do you see quantum and AI integrated into the maritime? We talked about it earlier in different ones, but I would like to have your opinion about it. And of course, from Christophe, because you were at NVIDIA, and I hope that you don't regret leaving NVIDIA today, so...
Right. So maybe let me give you an example in one field. Within the maritime industry, I think there's many interesting use cases that relate potentially to materials and chemistry-related things. So think about corrosion. We heard it a couple of times as a key use case. Maybe new materials for fuel cells, maybe composite materials, new alloys, maybe all kinds of energy systems. So a whole bunch of things relate to chemistry. So how do AI and quantum come together? Well, I think what we're interested in, if we are trying to develop innovative materials, is much more than just getting some energy state. Right? We want to make sure that we create materials innovative, that are manufacturable, that are economically producible. And for that, quantum computing is never going to be enough to solve that. We can use these combinations. If we use them together, that's a really strong, the best combination. So potentially we can use maybe AI to predict new material structures from huge data sets and predict thousands of new structures with desired properties. Scan through large databases of literature. Maybe we could use quantum chemistry tooling on high-performance compute to predict certain properties of those materials. And then maybe part of those quantum chemistry pipelines we can outsource to a quantum processor. Maybe using those type of, then we have new materials. Maybe we can use virtual testing in combination with experimental testing to test those hypotheses. Maybe all that will go feed back into sort of a database that we train new AI on and eventually test new materials. So it's really that combination and convergence of both AI to predict structures, of quantum chemistry pipelines to sort of go very deep into properties that are hard to predict with just AI, and the combination of physical testing that together will really change the way we can design materials. And then I think if we are able to do that, we can really have a completely new way of material design for the maritime industry, which is no longer like iterative and slow and uneconomical, but instead it's much more simulation driven. It's really purposeful. You can really design materials based on the properties that you want it to be.
What do you think, Chris?
From the beginning, I was convinced about this complementarity between AI and quantum. Just to give you a short anecdote, when I was at NVIDIA, I had a new business lead coming from Pasqal, and the purpose was is are we able to, I mean, when I was at NVIDIA, are we able to propose a cluster to Pasqal to do simulation, to do quantum simulation? So I had a team at this time, and I asked my team, who doesn't want to get this lead? No one, you know, would like to manage this deal. So I did it. And surprisingly, I jumped into Pasqal once the deal was done. So, but just an anecdote showing that for me it's an evidence. AI and quantum are linked on the software side, on the algo side, but are linked as well on the infrastructure side. Today we are working not only with NVIDIA but with IBM on how to do hybridation and how to use the power of HPC cluster, so powered by GPUs mainly, and how to combine these two kinds of technology to resolve some concrete problems. And on the algo side, we already proved that quantum will not replace any GPUs, but could help by train some part of algorithm, specific part for sure, but could help to train more efficiency, more efficient to train this model like LLM or in the financial vertical. We prove with a French bank that we could replace some specific part in order to help AI to be more efficient with less data needed to improve and to train the AI model, for instance.
Thank you so much. So my last question, and to close this panel and the day, to ask you both, your intake from the full day and the panel. So it's like, I'm going to use it for my for my report. So can you tell us? So can you tell us what is the outcome of what you learned today, like quantum, AI, and maritime? Can you put them together to give probably 3 outcomes that you've seen today?
I like the idea you are pushing, Malak, on the fact that quantum is one. I mean, quantum sensing, quantum communication, and quantum computing today are 3 different pillars, but at the end, for a specific verticals, it could be linked. And I think for me, it was the main outcome of today, and to see this linked, and it could be possible with this kind of conference.
Because at the end of the day, they are the pillars of the technology. And together, if we want to look not in narrow way and each technology separately, we can see a bigger picture and the integration of the technology within the other systems, which can bring a new way of how we see innovation. So this is the thing that I've seen always, is everything as a system, that they are interconnected. So please, Julian.
So I think what we need to do as an industry is really go beyond the generalities, right? We had enough time to talk about what is quantum, and first algorithms. We need to go into what does it mean for specific industries. What does it mean? What does quantum mean for finance? And now can we go much deeper, not just portfolio optimization, but what does that mean? And I think that what this conference does really well is to really dive in what then does it mean for maritime industry, because that's, I think, really what helps people.
Thank you so much. And it's alhamdulillah, first of all is alhamdulillah, is thank God for this. And the second thing is thank you, Dr. Yasser, because of your leadership this took place. And thank you for your trust, and thank you for the belief in the innovation, because this is one of the most important things. And for your vision to see that quantum is important.